Which homework am I looking at?
What?
Which homework am I looking at?
Oh, from 3.2.
Okay. Oh yeah, I did all these problems yesterday in Flex, but I'll do it again.
Thank you.
I do record Flex, so sometimes you might just check that folder, because the problems are labeled, or I usually say kind of what I did. So, all right, so I'm writing a logistic function. So it's going to look like this. And I have to fill something in right off the bat. So look at what's given. What can I fill in immediately?
The initial value?
Nope. I can fill in the initial value in an exponential, but not in a logarithm, or not in a logistic. In a logistic, I'm going to have to work out the initial value. And first,
the growth is 1.6.
Okay, wait. I'm doing problem number 2. Is that right?
Mm-hmm.
On 3.2? Right?
Yeah.
Okay. The limit to growth, you need to remember this number is the limit to growth. So you are going to stick in 60 for your numerator. Now, to find or to use the initial value, you have to remember that in all equations, the initial value is 0, comma, whatever. The initial value is the number that is paired with 0. So in this case, that point would be 0, 20. Right?
Mm-hmm.
So now I'm going to plug that point in. So 20 goes in for y, and 0 goes in for x. Now, like always, anything to the 0 power is going to be 1. So basically, I have this equation now. Right? So I will do what?
Solve for b.
Yeah, how do I do that? Yes, you're right. How do I do that?
Multiply it over to multiply the denominator.
Mm-hmm. And that's going to be a distributive. So you're going to have 20 plus 20b equal to 60. So 20b equals 40 and b equals 2. So right off the bat, I knew A was 60. And now I know B is 2. So I'm just going to squeeze it in right here. So now I'm looking at that equation. Okay? Now what? Look at your problem. There's only one thing left. What's left?
B.
Okay, what have I not used in my given problem there?
The point. So do we just plug the point in?
So now I'm going to plug the point in. So I'm going to plug it in right here. So I'm going to put in, what is it? 12 elevenths equals 60 over 1 plus 2 c to the third. Right? Zane, I need to see you or this doesn't count.
I'll just wait until we started talking about something that I actually know, because I don't know that stuff that's on the board.
Yes, you're right. You're right. That's because I have different kinds of classes. But it wouldn't hurt you to pay attention here, because some of this is stuff you can use. All right. So, Caroline, what am I going to do now?
Do multiply over Again, or do you do cross multiplication?
Well, I would cross multiply because you've got two denominators. So I'm going to cross multiply, so I'll have 12 plus 24c cubed equals 660. 60 times 11. So 24c cubed, I'm going to subtract 12, that's 648. Now I'm going to get my calculator out because I'm going to have to divide by 24. And that's 27. So c cubed is 27, which means c is what?
3.
Yeah,
Or
yeah.
3.
I just cube root both sides. And the cube root of 27 is 3. So this number is a 3. And there is your equation.
Okay, that makes sense. Thank you.
Okay? Now, if you have another one, you can wait. I'm going to get one of Zane's, and then I'll come back to you again, okay?
Okay.
All right, so Zane, what's your question?
I had a question about the LNEX problems that we went over today. Like, I didn't really understand, like, the E thing.
Well, I don't want you to be confused by it. ln is simply the symbol for log base e. So we have log base 6, we have log base 10, we have log base 17, we have whatever base we want on our logarithms.
Okay.
When the base is e, that is used so much that it has its own special symbol. So on the calculator, they could have put that symbol. They didn't, they put this one. But they mean exactly the same thing. Just like on the calculator, they didn't put log base 10, they used this symbol, log.
Mm-hmm.
So there's nothing any different about ln than there is about any other logarithm.
Okay, so, like, when you, like, answer, like, a problem, is E always in your problem, if that makes sense?
It can be in the problem. It doesn't have to be in the problem. But if you have ln x equals something, I'll say 5, then E is going to be in the problem because you're going to loop-de-loop this. That's the only way to solve it, is to do a loop-de-loop. So you need your base, and your base is E. If the problem is an ln, the base is going to be E. That's because that's what it is. So this would be e to the 5th equals x.
Yeah. Okay.
So I mean, obviously E isn't part of every problem in the whole wide world, but if you have something that looks like this, yes, it's going to be.
That's what I meant. Like, when it's just, like, by itself.
Yes, because your base is E. Yep.
Okay.
All right, your turn, Caroline. Find another one, Zane. We'll get you after we get her.
Okay.
On the quiz that we took today,
Yep.
I got, like, find the A, but when you find the B, would you just plug in
Okay.
the other?
Yes. Can you give me the points again? This is right, the exponential.
Yeah.
Okay, Zane, you need to know how to do this too. What are the points?
0, 4, and then 3, 27, 16.
16ths?
Yeah.
Okay. So you knew right off the bat that A was 4, because that's your initial value, and we know the point with the 0 always is the A. That's the initial value. Now, we don't know that in a logistic function, Caroline, so remember that. In a logistic function, we start with the limit to growth, okay?
Okay.
But in an exponential, this will always be your A. So then, yeah, you just plug in 27/16 for Y and 3 for B. What will be our first step to solving that? What do we need to do before we do anything else?
Divide by 4.
Yeah.
Or by 4.
Yeah, you can do either one. I prefer, since this is a fraction, I prefer multiplying by a fourth. But remember, back from like third grade, multiplying by a fourth is the same as dividing by 4. So do it however it makes sense to you.
Okay.
So we end up with b cubed equal to, multiply straight across, 27/64.
So then we take the cube root
Yep.
of both the
Yep.
denominator and numerator.
Yep, we need to know what b is. So we're going to cube root 27. What's the cube root of 27?
3.
Yep. And we're going to cube root 64. That's an easy one too.
16, no.
It's actually 4. Because 4 times 4 times 4 is 64. Now, once you figure out what b is, don't forget to go back and write the equation. So the equation is 4 times 3/4 to the x. Because your a was 4 and your b you just worked out to get 3/4.
Okay, thank you.
All right? Your turn, Zane.
When you have 2 points,
Yep.
how do you do like the exponential function thing?
Okay, that's what I just did. That's exactly what we just did.
Oh.
Here are the 2 points. So the first thing we do is recognize the point with the 0 gives you your a.
Mhm.
And then, well, I kind of did some work on it, but then I just plugged this point in for x and y. So I had 27/16 equals 4 times b to the third. Plug this in for y and this in for x. And then you can see all my work. I multiplied by a fourth. So I had b cubed by itself. And then I cube rooted both sides so that I could figure out what b was. And it turned out to be the cube root of 27/64. Then I went back and plugged it into my equation. So that's my a value and that's my b value.
Okay.
Now, if you have another one handy, I can't make these up off the top of my head.
I have one right here.
All right.
The point for 0, 2, and 1 and 6.
Okay, that's gonna be an easier problem. Okay, so we start the same, we know we're shooting for a times b to the x. That's an exponential. And we know our a is 2. So then we just plug in the other point.
Which would be 1, right?
Well, you plug in 1 for x, but you gotta plug in 6 for y. You gotta plug them both in. So 6 equals 2b to the first. Then you'll divide by 2. So b equals 3.
3. Okay.
And then your answer is 2 times 3 to the x, because your a was 2 and your b worked out to be 3.
Okay. Oh snap. And then, on the front page, when it says like y equals 1/2, and then parentheses 0.83. And then it has
Hopefully
a,
to the x.
What are we supposed to do with that x? I'm kind of confused with that.
Well, what are the directions?
It just says which are exponential functions. If they are exponential, state if they are growth or decay, state the rate of growth, decay, state the initial value.
Okay, so you're not doing anything with the x. You're just taking a look at this and first of all deciding if it's exponential, and if it is a number raised to an x. So if it's 0.83 or 1.75 or 18, whatever it is, raised to the x, it's exponential. So this is an exponential function. If you had something like x to the fourth, that is not exponential.
Because it's not raised to x.
Exactly. It has to be a number to the x. Okay? So that makes it exponential. This is your A, this is your B. Well, we already know that the initial value is 1/2 because the A is always the initial value. This number is 0.17 away from 1. 1 is the key. 1 is like your starting point.
Yeah.
This is 0.17 less than 1. So this represents 17% decay.
Decay.
If you are less than 1, you're decay. How much you're less than 1 is your rate, or whatever it said, percent, whatever it said.
And then if it was more than 1, that would be growth, right?
Yes. So if this number had been 1.13, now we are 13%
growth.
growth. Yep, 13% growth.
Okay.
Okay. Hey, Reed, you gotta stop doing this, man. You gotta start coming at 2. Flex starts at 2.
Oh, okay. I was just okay.
Okay? So this, you gotta quit coming in so late. I'll take your questions, at least a couple of them, but you need to get here on time, all right?
Got you.
All right, Zane, one more. What do you have for me? And then I gotta do one for Reed.
Okay, so still the exponential things, or like what we were just doing. So what if it's like 5x and then another x on top, if that makes sense?
Well, it's not exponential because
it says y equals 5x and then it's raised to the, like that.
Yeah. Okay, but exponential, this has
You
to
have to
be
have
a
the a
number.
and b in parentheses.
Yeah,
Right?
you gotta have a number here. So it has to be like 5 times 2 to the x. That can't be an x. Okay, so that would not be exponential. This one is not. All right, so hang on, find another question. I'm gonna do one for Reed. Reed, what's yours?
Mine was just over question 1 on the 3-2 homework.
Okay. See, if you came on time, you would have all this. So now I'm doing the same problem over. That's what I do not want to do. Oh, okay, so it says, oh, I just wrote the answer. I'm sorry. Well, that's the answer. So why is that the answer? Because we're starting with 3,000 people. So our initial value is 3,000. And when we write an exponential, this is the initial value, always, the number out in front. So I'm starting with 3,000. And then my population is growing 10.5%. So 10.5% is 0.105. That's the decimal for 10.5. Since it's growth, that has to be added to 1. If it's decay, it's subtracted from 1. Since it's growth, it's added to 1. And that's it.
Okay. That's pretty much all I have. I'm pretty sure I have all the other ones done.
Well, I know you have at least one of them done because we did it yesterday.
Uh-huh.
So the only one is the last one. I don't think we did. I did it, but before you came yesterday. What do you have?
No, I had the last one. I just didn't get. I did number 2.
Oh, okay. So we got the last one. All right. What did you get for number 2?
I got y equals 60 over 1 plus 2 parentheses 3 in parentheses to the x.
That's exactly right. So you did that correctly. That's exactly right.
Awesome.
All right. Zane, what about you?
My last question was about, so remember on the quiz how like the first one was 6 times 3 and then like the negative was on top?
Okay, so what, it was 6 times 3 to the negative second, I
6
think?
times 3 and then a negative, like that.
Yeah, okay.
So when you have the negative like that, I know you flip it,
Mm-hmm.
and then.
So it would become 1/3.
Mm-hmm.
Okay.
Okay.
So
and then
now.
once you square that,
Mm-hmm.
you get 2/3.
No.
Or target.
What's 1 squared?
1.
Uh-huh. What's 3 squared?
9.
Okay, so you get 1/9.
And
Okay.
then
Now we gotta times it by 6 over 1.
you get 6 over 9.
Yep.
Then you simplify.
Yep. So 2/3.
God. Okay, so you can make the flip first, like you don't have to wait.
No, you
So I
have
wait
to
till,
make,
like, the last
no,
minute.
no,
Like,
no,
not
no,
the last minute,
no,
like when I put
no.
my answer down.
You have to make the flip first. You
Okay.
have to make it first. So when I look at this, PEMDAS, I gotta deal with the exponent first. So the 6 has to wait. The first thing I do is deal with the negative. Always, always, always. So flip it, and then do whatever else needs to be done. In this case, squaring it, but the flip happens right off the bat.
Okay, I got you. I was doing it at the end.
Okay. That would cause a problem.
Well, thank you.
Is that it?